128 of main memory. Now you have cache of 32. Okay, the block size is 8. So then you know lah how many physical address. First you calculate the physical address. So formula ingat lah, to the power of n. So to the power of physical address is the same goes to the memory size. So 128 to the power of 7, the physical address ada 7 bits. So your block will get 7 bits. 2, 2, 3, 3, 4, 5, 6, 7. So you will have 7 bits. Okay, at this point you don't know berapa tag bit, berapa block offset, you tahu lah. 8 to the power of BO equal to block size. So to the power of 3. So 1, 2, 3 is the block offset. Apa yang 4 ni you tak tahu. Okay. Untuk associative mapping is easier. So associative mapping, we call it many to many function. Tadi one to many dan many to many function. Maksud dia, any block can be in any cache line. Dia boleh kat mana-mana yang available, you can slot them in. That's what they call many to many. So dia tak ada cache index. So of course the cache dia ada address dia. So cache index 32 bahagi 8, you ada 4 kan. So ada 4 line. Still 4 line with 2 bits. Okay. But because it's many to many function, any memory block inside the memory can be mapped at any available cache line. Kalau dia tak available, you can ada swapping lah. So perasan tak? So tak ada cache index diperlukan. So what happened to this physical address? Cuma ada tag bit. So tag bit here, tadi kan yang first tadi ada least significant, most significant. Dia tak ada sebab tak ada cache index pun. So the whole blocks index can be placed into tag bit. So how many blocks index? 128 bahagikan dengan 8 dapat 16 kan? To the power of BI, blocks index is 16, so BI is 4. So ada 4 bits. So blocks index ada 4. Blocks index will be placed into tag bit. So tag bit ada 4 lah, betul lah. 1, 2, 3, 4. The whole tag bit. Dia akan jadi dia punya unique identifier. So tapi how to map? It can be at any cache line. Tak kisah. Tadi dia kena tengok kumpulan cache line kan sebab ada most significant bit, least significant bit. Here you don't have to worry. Dia masukkan sahaja. Kalau ada, katakan dia ini kosong, so dia akan masuk lah. Ini kosong, dia masuk. Dia masuk. Kalau dah penuh, then adalah swapping algorithm lah, replacement algorithm. Ni we call many to many. Ni tak involve banyak pengiraan. You just need to know how many block line, how many cache line, and then how long is the physical address. And then this is the field look like TB and BO sahaja. Faham tak guys? Senang kan? Yang ini senang kan? A little bit easier. Bukan little bit, memang much more easier to understand. Boleh? Dah faham? Okay, good. Now the third one, the final one. Ni cepat je lah habis kelas kalau semua faham. The final one is digesting, Rebecca. You kena buat latihan. It's quite simple. It's just that you must know what is most significant bit, what the least significant bit. You can refer back to my note yang Word document tu saya dah type it properly. Yang tadi maybe kata berjauh sikit lah. So here now, it's a set associative mapping. First thing first, you must understand the definition of mapping function. To map between what? To map between memory and cache. Involve the block transfer. Dalam memory banyak block. Cache line awak tu kecil. So you must know which memory block go to which cache line. And yang itu kita belajar sekarang. Kalau yang tadi, baru tadi, associative mapping is many to many. Any memory block can be at any cache line. Kalau direct mapping, dia kena ikut group of the cache index, the least significant bit. Tengok, kalau 00 kat belakang dia boleh masuk dekat cache index 00 sahaja. Macam tu. Okay, now is set associative mapping. Set associative mapping is the combination of number 1 and number 2. And it's more flexible lah, efficient ya. Okay, yang ni saya rasa saya nak guna nota daripada itu, senang untuk saya lukis banyak-banyak. Okay. Sekejap saya guna nota yang saya upload tu. The same thing, the same number, same. Okay, now is the set associative. Okay, set associative mapping. It's a combination of direct mapping dengan associative mapping. Okay, now advantage to reduce the number of tag bits such will be reduced. Okay. The grouping is done in K-way. Ini yang paling penting is apa K-way. A number of set. Okay. Kalau you rujuk dekat buku rujukan, ada kata N-way, S-way, sama je. K is just a variable. K here is represent a number of lines in a set. Okay. For example, two-way set. Two-way set meaning, apa maksudnya? Need to segregate the cache into the set, each of size. Okay. Guna yang sama. Kita tahu lah what is the physical address ya. Dan sama you dah tahu lah 7 kan. So the physical address ada 7 bits. For set associative, you akan ada tag bit, set index, and of course offset. Kita tahu lah 8 kan. So 3 bits. So set index dia kata 2. Kalau 2 how to get set index? Okay, number of line 32 divided by 8, you got 4, right? So kita gunakan set associated mapping. So dia kata, let's say the question said is two-way. Dia boleh letak 4 ke 6 kan? Katakan contoh 2. So number of set, number of line 4 divided by K. So you will get 2 set. 2 set. And then what's the index? To the power to the power of set. Get number of set. To the power of SI, you get dual. So what is the set index for? To the power of what? You get 2 guys. 2 kuasa berapa dapat 2? 1 kan? So to the power of 1, you get 2. This is the set index. So 1 bit with 1 bit with 2 possible combination. So 1 bit, kalau 1 bit kosong je lah. So kosong lepas kosong 1, so 2. Kan? Kalau 2 bit, kosong, 2 bit kan. So kosong 1. So dekat cache you akan ada 2 set. Set kosong, set 1. Dipanggil set kosong, set 1. Kosong, 1 tak ada. So set kosong, set 1. Dalam satu set ada 2 line. Ini. Dalam satu set ada 2 line of cache line. Set kosong, line 1, line 2. Set 1, line 1, line 2. How you want to map between block memory dengan cache? How? Cara dia sama dengan direct mapping. Sebab tu dia kata it's a combination of direct and associative. Kalau 4 bit kan, how to get 4 bits? To the power of bit. Number of block system. So, I adalah 4 bit with 16 combination. Them out, get start with 0. So which block can be placed into set 0 or 1? So you will refer to the least significant. Now set index is the least significant. Your set index is now the least significant. How many bits for set? 1 bit je. Kan? bit is from your right. So, satu bit. Index with least significant bit of 0 placed into set index 0. Kat mana line ini line? Dia ada dua line, so dia boleh letak sini, dia boleh letak sini. Okay. Kalau 1 macam mana? Kalau 1 dekat line mana, mana-mana. Tak guys? You kena tahu which one least significant, which one most significant. Itu sahaja. So yang 3 ni adalah most significant. Most significant ni adalah tag bit. So 3 dah. Okay, pening kepala. Okay. Faham tak? Yang ini you tengok balik lecture note ni. Okay, boleh? You guys get it? Hello? Hello? You seorang kita tak boleh dengar. Kalau you seorang tak nak explain. Guys? Can you hear me? Oh, I don't know lah. Semalam okay je. Semalam okay je. Kelas saya semua boleh dengar. Nampak dia tak dengar. Hello? Alah. So kat mana yang you miss tadi? So for set index, okay, for the set index. Hello, can you hear me clearly? Okay, good. Okay, I repeat guys. So for the set index, you ada dua. Saya tak tahu dekat mana you tak dengar tadi. Which part that I need to repeat? Which part that I need to repeat, guys? Part tak dengar. Yang lain tu tak tahulah buat dengar ke memang tak dengar ya. Okay, for set index, dia adalah combination of direct dengan associative kan. So you already know yang nanti you rujuk nota tu. Okay, yang ni kan memory. So you have a memory line or block memory ada 16. So now you have the set index kan. How to know how many set that you're going to have? It depend on the question. Contohnya question ni kata 2 sets kan, 2 sets. So you akan ada 2 set, but how many line you don't know yet. So the size is 32, right? So 32 divided by 8. So ada 4 lines. So 2, 3, 4 line. But we are using set associative mapping. So how many set? 2. So 4 line. 4 divided by 2, you got 2. Ini adalah 2 line, 2 set. So 2 the power of set index is a number of sets. Okay? To the power of, ni tadi saya rasa dengar ni ada yang jawab tadi, set index adalah 1. So meaning is 1 bit. So bit 0 and 1. So number of lines ada 2. So you divide by 2. Yang ni tadi saya rasa dengar jawab tadi. So 0 dan 1. So now question is how you want to map between main memory dengan cache. So you have 16 block, but which block can be in which set? Okay, you ada 2 ni, tak ada address, so dia ada 0 dan 1 saja. So, let's here. So your set index is the least significant bit. Okay, your set index is the least significant bit. But how many bits are? 1. 1 saja. So least significant bit is on your right. Okay. So 1 bit 0. So any blocks index with least significant bit of 0 will be placed into set index 0. Okay. So you can tengok yang dekat least significant bit. So 0, 0, 0, 0, 0, 0, 0. So Blocks index ada 4 kan, 4 bit. So least significant bit, blocks index with least significant bit of 0 akan masuk dekat set index 0. But in which line, tak kisah. Sebab dia ada 2 line. So any empty line, any available line, dia boleh masuk. So it's more flexible. Okay. What about set index 1? Okay, set index 1, you tengok least significant bit yang ada nombor 1. So yang ini dah 1 hujung. Tu yang kena tahu apa least significant bit. Okay. So yang ini semua akan masuk dekat set index 1. Macam tu je, senang je. Tautan ni semua ada. Boleh tak? Boleh dengar dan faham tak guys? Yang penting ni boleh dengar tak? Itu penting. Can you hear me now? Okay, thank you. Senang kan? So you have to differentiate between these 3 mapping function. Kalau direct mapping tadi dia ada cache index. Kalau set associative dia ada set index. Okay? And set index ni kat mana dia dalam ni kena ada ni, the whole thing is blocks index. Sebab dia dekat memory kan. So a part of the blocks index ada tag bit dan ada set index or cache index depending on the function. Tapi senang je. Tapi you kena, lepas saya explain ni, lepas habis kelas dia, you kena tengok balik dan buat. Kalau tak memang you akan lupa. Sebab dia senang dan senang nak lupa. Percayalah cakap saya. I do believe everyone understand this. Sebab bila saya explain senang kan, it's very quite easy. Tapi kalau you tak baca balik, you kan senang lupa. Sebab you have to differentiate mana most significant bit, mana least significant bit. Remember, least significant bit is starting from the, that's how I ingat lah, daripada kanan, kalau most daripada kiri. That is the way I memorize this thing. Kalau you ada cara lain, you boleh guna cara lain. Okay? Contohnya, the whole thing adalah physical address. Semua ada dalamnya, ada 3 dokumen saya upload. Okay? Tapi you boleh ubah sikit supaya lebih faham. Tapi this is how I write this. Yang ini sama sahaja dengan what in your lecture note. Tapi for me, in lecture note tu macam sedikit susah nak faham. That's why I come out with this one. Tapi senang je. Once you understand this one, then you refer back to your lecture note, it's the same thing. Sama sahaja. Do you have any question? Yang 3 ni. Ada set, kita punya 3, direct, associative dengan set associative. Ada question guys? Sebab hari ni kita bincang ni je sebenarnya. Yang lain tu you kena baca sendiri. Bila baca sendiri tu for me is quite theoretical, which is on your own you can understand. Yang saya highlight dalam kelas yang saya rasa perlu discussion. Yang lain tu senang kan? Kalau you go through the lecture note, you can you boleh tahulah yang quite straightforward. Maksudnya, what is the characteristic of cache, memory, location ni kat mana? Memory kan ada secondary, ada primary, secondary, lah macam external hard disk, thumb drive, flash drive, itulah. Dia ni baca sendiri guys. Yang ini yang saya paling risau bahagian ni sahaja. Yang ni memang kena explain. Kalau tak sedikit little bit it's not difficult, maybe confused. Okay. Nanti you tengok balik note-nya yang saya dah upload, already upload. Ni ada lah saya. Ni tengok balik. Yang ni dah cover semua ni. Ni sama, you nampak yang ini macam susah kan, sama saja. It's the same thing. Sorry, saya lupa nak satu comparator. This is what we call comparator lah. Yang hit dengan miss. Kalau miss maksudnya it's not exist in the cache. So dia kena ambil daripada memory, masukkan ke dalam cache. Kalau hit maksudnya CPU can find the address yang dia nak looking tu dekat dalam cache. Okay? Comparator lah, dia akan compare. Okay? Sama. Cuma dia ada panjang, so you can try the homework lah with 14 cache line. Sama sahaja. Ni ada explanation, dia proper explanation, maksud saya in proper English, in proper setting. Ni baca sama je. Okay, kita dah ni pun sama. yang okay. Yang ini tadi pun untuk computer architecture, replacement algorithm only learn by definition. Maksudnya list recently tu apa, tadi kan dah explain kan, FIFO tu apa. Tapi nanti in the next course, next semester, you akan ambil operating system. Dekat situ nanti you all akan belajar kira. Bukanlah belajar kira sangat pun, macam you akan belajar little bit further lah about this replacement algorithm. Dalam CA kita tak sentuh. Dalam CA only a definition, tapi dia ada method dia. Macam mana you nak kira berapa lama ada, nanti ada pengiraan dia. Nanti dalam, sebab tu saya kata kalau you have a very good knowledge dalam CA, nanti dalam operating system sangat senang bagi awak. Yang ini nanti dalam CA OS akan bagi lebih banyak. For CA only a by definition only. Tadi dah explain dia ada explanation dia, boleh baca. Yang lain boleh baca, senang je. Nampaknya itu sahajalah. If no question, ada soalan. Kalau tak ada soalan, nanti we can stop here. Nanti I will put the tutorial question, you guys can try. Okay, later on, maybe next week kita akan tengok lah. Next week or another week before your balik hari raya. Nanti kan exam akan lepas hari raya kan for your term. Alright. Okay, for your lab exercise will be released within this week. Lab exercise akan release within this week. Is also individual. Is just follow the manual. Maybe nanti ada benda yang tak boleh follow 100%. You have to find. You kena research sikit. You kena make effort. Okay, to make it happen. Ada benda lah you kena buat nanti kan. So and then you must submit it before the deadline. So ada 5 deadline. So submit it lab 1, hantar dekat lab 1, lab 2 hantar dekat tu. Please do not combine it lah. Sebab kita dah set macam tu. Kita buat satu. Nanti kalau saya buat combine semua, nanti student banyak lupa. Kadang-kadang dia hantar 3, kadang-kadang hantar 2. So nanti I will provide the link, separate link. Lab 1, lab 2, lab 3, lab 4. So please submit in that particular lab before its deadline. Kalau you nak hantar awal boleh, tak ada masalah. 5 you nak hantar awal boleh, tapi make sure the correct link, okay? And before the deadline. And please do not email me your lab report or assignment. Semua through link, okay? I will activate the link and upload the exercise within this week. Boleh Okay guys, kalau mu tak ada soalan, I think we should stop here. We can stop here. Okay, if you do have question, you can ask me now. Okay, yang lain kalau tak ada soalan boleh beransur lah, and I will share the the standards. Kalau ada soalan boleh tanya lah sambil-sambil saya tunggu kawan awak scan. Kalau tak ada boleh pergi kelas lain. Thank you guys. And happy wrecking your fast for the something.
Excuse me, madam.
Yeah.
Good afternoon. I have a question about the assignments.
Yeah, what is the question?
Can I use the dedicated integrated GPU? I mean, I use the CPU which in integrate GPU. And
the question, if you read back the question give them to choose what specification that you want to have using your own kan. So anything that you choose, what I want to see in your report is your justification. Katakan tadi kata, can I use integrated? My question is why? Salah satunya why lah. So report, you explain why. Maybe I don't know about the price. Maybe the price is little bit higher than the normal GPU, and so you have to come with the explanation. Itu yang saya nak tengok. And then how is it relate to the other component? Sebab when you build the computer, kalau you perasan, kalau dekat kedai kan, RAM ada besar tapi CPU very low. So you have to explain. Definition of your spec tu macam mana? Itu yang saya nak tengok sebenarnya. There's no right and wrong answer, but it's how to put them into report. Itu sebenarnya. Boleh. Tak ada masalah.
And I have another question. Is that we only describe the CPU, GPU, RAM, and monitor only? Power supply and other things we don't need to
Okay, for
describe?
the simple thing, for example, keyboard, mouse, you don't
Yeah.
have to go for technical explanation. Like just enough you said, okay, this computer come with wireless mouse. Maybe you kata it's very latest one. Macam tu, you don't have to be technical. Tapi yang the main component tu kena a little bit technical on explanation.
So the power supply, all that thing, we also need to provide the price, or we don't need to provide the
You have
price.
to, kan ada bagian costing.
But excuse me.
You have to put the price.
Since the
But
questions
the
only
total you should put the total or like the total price of your computer.
not put each component price lah. Just
But
put
then
the overall.
nanti kan because you macam buffet kan, how you build your own computer, so the total
Yeah.
number of macam tu lah. And then you must be orang kata wise lah, because this is for student. Kalau student tak logik lah, komputer 8,000, 10,000, 7,000 tak logik kan. So try to make it like 5,000 and below. So you have to think this is for student. Even though we don't limit the price, but dia kena reasonable lah macam tu.
Okay.
Kalau you pergi kedai punya perasan tak dia jual, mana ada mahal-mahal for student.
So the power supply, those things we also need to combine together lah.
Kena lah, kalau tak macam mana.
But the Christians now say the power supply, those things.
The question is, the scenario is ask you to build the computer. So you can.
So the power supply fans and such thing we also need to
Tapi
discuss it.
benda tu tak payah you highlight sangat.
Okay.
Come out with the bla-bla macam tu saja. The main thing tu yang kena. Contohnya you pilih monitor kan, it's for graphic design student kan, you kata this specification come with 16 inch. I don't know 16 inch. Then you have to support, you have to justify. Itu yang paling penting. That's the most important thing I want to see. I just don't want student to simply list, okay, CPU contoh 16, monitor 16 is a very good. Then apa? What is the explanation? Tu yang saya tak mahu.
Okay.
I want to see the discussion in your report. You anggap saya macam client. Macam tu.
Okay.
Client yang nak beli komputer.
Okay.
Oi, mahalnya. Apa komputer.
Okay.
So you have to balance. Maybe your CPU dia punya spec macam ni, tapi your memory, so you have to balance benda tu. Not too expensive but powerful macam tu lah, macam tu.
So the motherboard also need to describe it.
Yang tu basic dia, you can list them out.
Okay.
So the price of the keyboard and mouse also need lah, and the speaker.
Tak jual kat saya ni. Because keyboard pun you many type kan, macam-macam kan, yang ergonomic lah.
And type B type. So the monitor need to related to CPU, right? Since the monitor is related.
Yes. You have to do research sebab benda ni.
Okay.
It's a research question. Kalau simply copy paste list, so what is the research, what knowledge that you get, betul tak?
Okay.
So bila saya baca, saya faham. You anggap saya tahu.
Okay, understand. Okay, thank you, madam.
Okay, tapi contohnya keyboard tu tak payahlah explain banyak. Dia cakap it's ergonomic keyboard with the price bla bla bla. Pandailah. Kan?
Okay.
Okay, thank you ya. Okay, bye-bye guys. Okay guys, kalau tak ada soalan, siapa yang tak boleh can leave your metric number